Yeah, good morning, one and all. I'm Praveen Kumar. So today we are going to solve a real world problem, and the problem is if you are having microservices and asynchronous APIs. So when a request fails, you need to know where does it fail and how does it happen. So if you are not having any observability framework, then it would be a nightmare in production ready systems. So today I solved this problem by implementing an observability stack for an REST API. Think of it like an e-commerce API using OpenTelemetry and Prometheus, Grafana, Jaeger. How I have implemented system and all the things we'll be looking in this video. Just wait for a moment. Yeah, the objective. We need to build a fully instrumented REST API with integrated comprehensive production grade observability. So as you know, observability means we need to know what happened and why it happened in production ready systems. So the stack I have used is OpenTelemetry. So coming to the documentation of the OpenTelemetry, yeah, it is also known as OTEL, a vendor neutral open source observability framework for instrumenting, gathering, collecting, and exposing telemetry data such as traces, metrics, and logs. So there is a difference between traces, metrics, and logs. Trace is nothing but it is an end-to-end journey from of a request from end to end of the process. I mean, in an application. And metrics will be are nothing but useful for calculating the load. I mean, when there are multiple requests, for example, say 10,000 requests per second, our API, we need to store all the things, and finding the logs of the system would be a nightmare also. So then we move to system called metrics. It will be helpful for calculating the mathematical value, such as error rate is 4%. So like that we will be using metrics. And logs, as you know, logs are nothing but the response generated. You can find it in your command prompt. When a server is running, it will be logging the details. So this is the open telemetry. So coming to the structural architectural overview. So yeah, whenever an API enters our application, I mean our API gateway, it handles the first thing middleware. Is there anything middleware? No. It passes the request first step, and the business logic or service layer will be dispatching the background job. Along with that, it will be sending the metrics and spans. So coming to the difference between a trace and a span. A trace is nothing but a request's journey from end to end in a microservice. So for example, in a microservice, not a microservice, trace journey is from entire whole application. For example, if you say 50 microservices, the journey of the request, and coming to the span, an unique one, which is responsible for a small task in the journey. For example, calling a database, it would be a span. We'll be assigning a ID and calling it as span ID. So a trace can have multiple spans. For example, span B, span C is responsible for mocking a database call, and B is for awaiting for the response. So like that, we have multiple spans for a trace. So yeah, this system will works in this way. The business logic will be emitting spans and exposes the metrics at endpoint slash metrics, and executes a query the data access layer. So we are defining an order request in our system, and also it will be making an mock payment API, which will be make an delay of 100 milliseconds, which is nothing but 1 second. And yeah, as you know, Prometheus is an open source software for metrics, calculating the metrics, how many requests have been processed, and what is the error rate in the systems. And Jaeger, nothing but it will give you an UI for seeing the trace ID of a request, and the Grafana. So combining both these data sources in our data sources.yaml file, we'll be getting a beautiful Grafana dashboard UI where we can observe in graphs or time series, etc. So I hope you get an overview of the architecture. So yeah, you can access the project at this is my GitHub URL. So this is the architecture overview. And one thing, this application is completely Dockerized, so you can run it anywhere. You can clone this repo and make sure you have installed Docker Desktop on your system, because there will be no hurdle for this working on my system and not working on my system. Docker ensures that it will be running on every system, because it will be creating something called containers, and in that containers will be running this process. So this is the architecture and separate file for the architecture. So I forgot to mention that I have changed the diagrams from normal ASCII characters to the mermaid JS, which will be rendering in the GitHub UI perfectly. Updated to use mermaid instead of see, origin. So now they can properly render in this. Wait for a moment. It has to be rendered properly. Yeah. So Docker network, I have created a network called Observability Net, because our containers need to talk each other in our system. So Observability Net works properly. Our API endpoint is at a 080 port number, and the controller, which is nothing but our gateway. Same as you saw in the architecture overview, this will be working like that. All the matrices and traces combining will be creating called Grafana dashboards. So all the things I have covered, and the metrics I have cust- defined as HTTP request total. How many types, how many number of requests have been happened, and each request taking how much, how many seconds, and the orders created total, and also failure, how many payments have been failure. Okay, let's get into the implementation details. So yeah, first step is to create a Docker Compose defining our services. One is the API, which will be created from our custom code, not from any predefined image. So if we are using any predefined image, we will be using something called image colon the image name in this way. But if we are building the image from our custom code, it will be created by using our Docker file. So yeah, we are running this project in a Python environment, and inside the Docker, we have been creating an slash app folder. So copying the requirements.txt and installing inside them, and copy dot dot means we are copying the whole code, and the command to run the server. Sub the port I have designed, and the observability network means whenever we have created a Docker compose, it will be creating an custom network inside the Docker, so that every services will talk to each other based on the container name, not the local host we are using. So the Grafana, and the image I have used Grafana slash Grafana. You can get it from the Docker Hub. So yeah, driver bridge means they can easily talk with each other. So yeah, we have defined the endpoints and observability the slash Prometheus. So Now I want to explain the how each thing works. Prometheus is nothing but a push model, not push model. It's like a pull model. It constantly, I mean, based on our time given, it will make a get request to our API endpoint and scrapes the logs and converts that mathematically to metrics. For example, error rate is this much and successful rate is this much in our API. So I have created a 5 seconds interval. So the Prometheus will make 5 seconds. For every 5 seconds, it will be mocking our application. The port number we have defined API, and next thing is Jaeger. Jaeger is defined open source model distribution system model defined. I mean created by Uber. It will be helpful to see the entire request journey. It is in push model. We'll be pushing the JSON data to the Jaeger, so it will make the UI visible to everything. And the next thing is Grafana, combination of both data sources like Prometheus and Jaeger. Yeah, we'll be defining in the observability folder of Grafana, provisioning and data sources. Yeah, based on the command we have given in this file, it will be rendered in the Grafana UI. So Grafana UI itself is in read mode. How we are defining or how we are writing in these data sources, it will be affected on that state. So the data sources we have created are one is Prometheus and another one is Jaeger. So Prometheus for scraping the custom metrics and Jaeger for traces. And we have also defined the URL of it. And you can see that why I am using exemplars. So exemplars are nothing but a specific function for each trace ID. So in short, we can say specific trace ID attached to a single function or single metric. You can see that in the practical demonstration. And yeah, next phase, the core API and background job implementation. Here we have different models such as data model, and it acts like an pedantic validation. It checks the validates the incoming request and converts to the Python objects. So the product ID should be integer and the quantity should be integer only. If everything is correct, it will be passing the request to our business logic or service layer and the background worker. So we have made the system asynchronous, meaning it will not freeze the server and waits for the request to be completed. So for example, for a practical demonstration, async and await will be helpful to make application working faster. Not faster, it feels the user to be working faster because the user does not want to wait for an event notification. He can use the application because the server will be returning with 200 status okay response, and after 20 milliseconds it will be sending the confirmation mail. So we don't need to wait until the SMTP server has to be running. That's it. And controllers, services, and repositories. The controller layer and the service layer. Here it will be useful for processing out payment. So I have been using httpx.async client, and we are mocking an external API, which is nothing but you can see that http bin.arc.delay, which will be making a 1 second delay. So the error handling, exception handling, if everything is well done, will be emitting success, and If any request has been failed, we'll be returning false. And the control layer, how an order will be created in the database. So the request should validate the order request identic model, and the background task are nothing but to send confirmation mail. So yeah, uh, you can check the application code. And another thing is the metrics endpoint. So we have Prometheus, which will be helpful for giving our metrics endpoint. You can see that practical demonstration and logger.py. So once an event or a request has been entered, it need to generate some response. So how a response should be, I mean, we'll be creating a logger. And I forgot to mention one thing. We have used context propagation, something called context propagation. So carrying a metadata like correlation ID or trace ID for every function and service layer, it should be difficult. So for say if we have 50 microservices and 200 functions, so every function signature should be changed to include that correlation ID. So context where will be helpful for setting the correlation ID, I mean the trace ID once, and it acts like a global context. And it will be helpful for strict isolation. For example, request A and request B are handling some data for users. If both request at exact millisecond, so what will happen? They will override. So context where will be helpful for not overriding the each other. So the log data, how data should be, and for each trace we are generating the correlation ID. So as mentioned, trace ID and span ID. So that trace ID is nothing but an request journey from end to end until the response is generated, and a span ID is nothing but a small task such as a database query and mock API call. So it is represented in hexadecimal of 32-bit and 16-bit of hexadecimal. So I hope I have covered everything. So let's make a practical demonstration. It's in resume state. Okay, let's start the work again. And I forgot to mention one thing. I have created a test folder which will be helpful for automated verification script. So it checks for whether the API is held on port 8080 and whether the metrics endpoint is correctly returning in exposure format, and the required metrics is everything is covered or not. So yeah, let's run the. So I haven't seeded any data. Let's see whether this works or not. Yeah, it's responded with API response on 200 health and metrics returns endpoint 0. So all the checks has been done, and let's generate a load test on our system. It's load test, not load test. So we are sending 100 requests, and the concurrency will be 5. So meanwhile, we'll be exploring the dashboards of Jaeger and Prometheus and Grafana. So first we'll be getting to metrics endpoint. So here we can see the total orders created and the total number of failures. So another concept I forgot to mention is trace ID. tracing sampler. I have defined that in custom middleware. So yeah, for each request will be extracting the X correlation ID. If it is not present, we will be generating a new one. Yeah, one thing I forgot to mention is trace ID ratio based, and I have set it to 15. I think 15%. Yeah, 0.15 means 15%. So I have set it into 0.15 instead of setting the 100%. So if our application hits 10,000 requests per second, and it will be generating hundreds of megabits of JSON data, so we don't want to store everything. So just we will be setting something called 15% of the JSON data only, the logs. Why 15%? We can also set something. So how tracing id by ratio works is, it will converting the trace id to hash and generates a virtual rolling die of 100 faces. If it is below 15, it will be able to send to Prometheus for metrics calculation. If it is above, we'll be just simply drop the trace. We don't want everything to be calculated. So the main bottleneck will be performance will be decreased. So instead of handling the request, we are calculating the request performance more. And another thing is cost. If the application is running on cloud models, cloud services, it will be taking a lot of amount for running the services. So that's why we'll be setting to trace ID by ratio. You can see the total of 100 will be created will be 39, and the failure will be 60, and some other. So Grafana will be running on 3000 port, and the credentials will be admin and admin for everyone. You can get it because we are using something called Docker desktop setup. Yeah, the business KPIs. So the total number of orders created and the total number of failures. So we'll be getting the time series based data, and also something called golden signals, the error percentage, and P95 latencies means how many 95% of the requests are faster than or slower than the X milliseconds, how many requests has been done. So we will be getting all these things in the Grafana dashboard. If we want to access the Jaeger UA, we need to see the complete request journey. You can see the 1468. Yeah, getting. So you can see the application's journey about each time how it will be processing. I mean how it has been traveling. So yeah, this is our complete system. and I have stored that values. I mean, we can simply export that Grafana's dashboard in a JSON format. I have already done that too. So yeah, that's it. How I implemented an observability stack for our REST API, our e-commerce API, using some observability frameworks such as OpenTelemetry and Grafana and Jaeger and Prometheus. That's it. Thank you. If you have any doubts, please comment down. Thank you. And the GitHub URL will be given in the description. Thank you.